This is a booster pump control panel. It consists of 4 booster panel, 4 booster pump. This is 1, 2, 3, and 4. This one we call it HVAC drive. HVAC drive. HVAC drive. HVAC drive. All in another term we call them variable frequency drive. That one variable frequency drive, VFD. But now this one is a smaller one. HVAC is a smaller one. It's a smaller drive. And now the other one, which is VFD, but it works the same purpose, though the settings are different. This one you can see the settings are here. Everything you set at here. Everything that you need, you will do setting here. These are contactor. You can hear the sound of on. This one is running now. You can see showing kilowatts and volts, which is running, the volts which is consuming, and also the kilowatts. Tell you it's a auto remote current high. It's auto remote. You can see now it went off. It's automatic. So as you can see, showing now you auto remote standby. All are at standby. They are controlled also with a pressure switch, which is connected to the motor. You can see now the next one now is running, the second one. Because the setting is to ensure that it's not only one motor which is running, both are running, all the 4 are running. If there is a lot of pressure, it can run 2 or 3 according to the demand. Now 2 is running, as you can see, voltage and kilowatts. It shows you that the current is already there. You can see the current is 6 point. Yeah, now it went off. These are the 4 booster pump. As I told you, they are 4 in number. I told you there is a pressure switch. This is a pressure switch. This one, as you can see, this is a pressure switch. We call it pressure switch. Pressure switch. This one, it's controlled by, it's an electrical controlled by the pressure of water according to the demand. You can see this is a pressure meter. So this pressure switch, it's the one which sends the command to the relay. Then the relay send command to the contactor to start or to switch off the system. If they need, it is needed more pressure, then it can switch on 2 or 3 pumps simultaneously all that is 1 by 1, and if it's running one and went off, then when there is another demand, it will not start from the one which was off, it will start to the next. So it is set like that. Also this one is a pressure control switch, also this one for BMS to send the command that it is demanding a lot of water, because this is out, chilled water out, domestic water discharge line. So the water comes from that side to this side, then it goes to the facility. From this it gives the command, from the other switch it gives the on command. So they work together. Also this is a switch, also a pressure switch, which is controlled, but this one controls the all of the command after command, all are connected in the series to ensure that if one fails, the other one will work. Then we have this another one. Also this one is a, you can see, hot water circulating pump. Also is a booster or circulation pump. These are smaller in size. As you can see, they are smaller in size, but the system is the same. This one is running while this one is off. There are two. From there we have these two pumps. These two pumps, you can see, is a booster pump. Also booster pump is a control panel. This one has no VFD, so it's controlled by we call it computer or the controller. This is the one which is running, this one is off. There are two booster pump. It is the same system, you can see. This is a pressure switch. Is this cable which is connected there for that pump, and for this pump also it is the same. It is connected both for the pressure. If this pressure is demanded here, automatically this switch will operate. It will send command to the panel, then the panel will switch on the motor to run. This is the HVAC, a very small one, HVAC. You can see this one. The current is running, I don't know whether you can see it. The current is running at 1.66 amperes with 46.8 hertz, 0.33 kilowatt. It's a very small motor. It's a small motor, not very small, but a small motor. Though it's not that small because it is 5 horsepower, but the demand is not that high, so it will add up the speed according to the demand. As you can see, the pressure or the demand is lower, so the frequency is down. The set point for the frequency, as you can see, this one which is off is 50. Set point is 50 at 100%. So this one is running at 47, 46. So this is 2. All these are for the control in the panel. These are small motors, 1 horsepower, 1.5 horsepower. They are this one, they are small. Also, it's a 3 horsepower. As I told you, this one has no VFD, so it's controlled by this one. This one is its controller. We call it computer, this one, because all the settings are here. Everything is set here. So this one is the setting computer. This one is which we set with it, as you can see, showing you the pressure. Manual, auto. This one is for setting manual and auto. This one is menu. This one is to set motor 1 and motor 2. This one we call it escape. So that's how it works. Here we have these two contactors, and we have these two isolator, or we call them in another way. It's a contactor which is a switched selector with a selector switch with a test switch. Then we have these fuses, and we have transformer for step down. This is a main isolator. It's a small panel. These cables are BMS cable, and this one are electrical cables. This one electrical cables for the motor. Remember, these are small motor.